Good afternoon. I'm Deb Powers, and I'm a manufacturing engineer for the surface mount and plated through-hole board areas. Today, we will walk you through the life of a PC board, from design to stock. Let's start with the PWB design area. After the design engineer completes the design, the board is ready for layout. Layout begins with an electronic schematic, a mechanical outline or size definition, a parts list, and a net list. Let's go see Glenn Proctor, supervisor of the PWB design group. Glenn has been generating PWB layouts for over 21 years at EMS. Glenn, what are you doing?
I'm trying to decipher these hieroglyphics from engineering.
Why did engineering give you hieroglyphics?
I think it's a check on the net list. It's to see if I'm paying attention. This is a net list that we get from engineering. The net list defines all the part and pin connections that exist in the schematic, and we use the net list to give those connections to the computer. An example is address line 6 tells the computer to connect J2 pin 14 to U1 pin 14 to U8 pin 14. Once the net list is entered, the next step is to build the components in the computer. And here we'll place the last set of pins on the part. Once the components are built, the designer then places them on the printed circuit board. Once the components are placed, we connect them as defined in the schematic and the net list. Our driver circuits are extremely critical to component placement and conductor routing, so we manually do this using the computer. The less critical portions of the board can be routed automatically by the computer. The designer, though, must still use his skill to place the components in a manner that will let the computer do its job effectively. When the PWB is complete, a fabrication drawing is created that defines board size, hole sizes to be drilled, specifications, and copies of the conductor layers. Our more radical design tasks require a radical designer. Here, Forrest has created a circuit card assembly used by manufacturing to build the PWB. Emotional support from Forrest has generated a three-dimensional output to be used by manufacturing as an assembly aid and by mechanical engineering to ensure proper fit.
Let's talk to Pat Chernishkin in purchasing about ordering boards. Pat, what can you tell us about buying printed circuit boards?
Well, Debbie, an RFP is received in purchasing with prints, and I send it out to at least 2 or 3 qualified vendors for quote. After we receive in the quotes from the vendors, we place the order based on quality, price, and delivery.
Thank you, Pat. When boards are received at EMS, they are inspected to verify they meet the requirements of the spec and the drawing. Russ Barnes will tell us what kind of testing and inspection he does when EMS receives printed circuit boards. Russ?
When I receive the boards, I check a sample of the lot for hole location and bow and twist. I visually check the lot for solder mask coverage, misregistration of plated through holes, and cross-section evaluation. If they pass, they're sent to the stock room. If they don't pass, the QE and the program manager disposition the lot.
Thank you, Russ.
I'll bet you that when the board comes in, the connector will be on the wrong side.
I'll take that bet on an ATRJ board, 2-to-1 odds. I'll bet you the next low band board that comes in-house has peeling solder mask.
Nobody would take that bet, Teddy, at any odds.
Don't say that!
Excuse me, I just wanted to tell our viewers at home what our manufacturing engineers do to prepare to build a board at EMS. This is Lydia Hodges, and she's the manufacturing engineer for DCP and other space programs. Lydia, what is your primary responsibility on DCP?
Writing travelers.
Well, what's your secondary responsibility?
Changing travelers.
I see. Well, can you tell us just a little bit about travelers?
They change a lot. A traveler is a set of work instructions that the assemblers use to build boards. In addition to writing travelers, I also provide floor support to the operators in helping them solve problems. I also review parts lists and engineering drawings.
Thank you, Lydia. This is Teddy Harrell, the manufacturing engineer assigned to the ESG programs such as low band and ATRJ. Teddy, can you tell me what your favorite part of the low band program is? Okay, well then, can you tell me, what is your motivation? What keeps you going?
Oh, I'd have to say my motivation changes from month to month, kind of like my calendar.
Steve Lustig is our newest manufacturing engineer, and he is assigned to the wireless programs such as Prism and Nolar. He also programs the pick-and-place machine. Steve, what is your primary responsibility on Prism?
Figuring out how to put on shields.
And your secondary responsibility would be?
Figuring out how to take off shields. In addition to working with the wireless program teams, I also design many of the fixtures used in the surface mount and through-hole labs. In addition, much of the programming for our pick-and-place machines are done right here on the computer, using information provided by the program teams and the board designers.
Thank you, Steve. Almost all of the boards we process at EMS have at least some surface mount parts on them. Some are entirely surface mount. About 70% of the surface mount boards are double-sided. Now, let's enter the mysterious world of SMT. Steve, would you give us a tour of the SMT area?
Sure. Let's start with Karen Brock, who is the stockroom representative here in the Surface Mount Lab. Karen, could you tell us a little bit about what you do?
Yes, I fill all the kit requests that come through the SMT lab, and each kit consists of reels, which have to be pulled, and also IC tubes, and the kitting is done by Stacy Shamley.
Let's continue with Stacy Shambly, who is the parts kitter. Stacy, what are you doing right now?
I'm kitting parts. After Karen gives me the parts list, I make a waffle pack map, I make a reel list, a tube list, and a hand placed part list. And I put the correct size, the correct amount of parts in the waffle packs, and then I label the bottoms. And I kit all the different, I make sure they're loaded in the proper size waffle packs.
While the components are being kitted, some parts require additional prep steps. Ceramic leaded parts are tinned and formed. Deborah Bowling is forming a part right now. Deborah, can you tell us what you're doing?
Yes, this is a lead former, and it variously changes the parameter of the leads, small parts and large parts, and just gives us different measurements of sizes. Okay. And then it is placed into a waffle pack.
This is our stencil printer, which is used to put solder on the boards. Bill Wilson operates this machine. Bill, could you run us through the setup and operation of the stencil printer?
Sure, I'll be glad to. The board's placed here and clamped in. Using the camera system, we can visually align the board for printing.
Thanks, Bill.
You're welcome, anytime.
Once there is solder paste on the board, we place the parts using the pick and place machine. Reference marks, called fiducials, are used to align the board for the pick and place machine. This is one of our two pick and place machines. Let's see what it does. Reels of parts are placed onto feeders and the feeders onto the machine. Parts are also placed into waffle packs. To date, we have placed parts as small as 40 mils by 20 mils and as large as 240 pin quad flat packs. We've placed parts with as fine a pitch as 19.6 mils. The machine picks the part out of the waffle pack and brings it to a camera to check its orientation before placing it on the board. On average, the machine places 400 parts an hour, but gets up to a speed of 850 parts per hour. Once the pick and place machine has finished placing the parts on the board is sent through the hot air convection reflow oven. Fred Roberts will explain this process.
The convection oven works off hot air. It has rails here which the board sits on going through the oven, and the rails can be adjusted to accommodate the size of the board. Once it goes through the oven, the board sits on the rails, and it's got 5 different preheaters on that it goes through. You got an upper preheater, lower preheater. You also got a cool down zone. As it gets to the end, it cools the boards down, so when you take it out, you won't be burnt. Okay, now let's go see what's coming out at the other end.
Fred, what's this?
Oh, it works great for pizza too. Just kidding. Deb, your lunch is ready.
After reflow, the boards are cleaned in the water wash, inspected, and handed off to the through-hole lab for touch-up before going to QA.
The through-hole area does all of the installation and touch-up for wave solder, as well as the touch-up for surface mount. They also install and solder all of the through-hole parts. Ethylene is the line leader for the space group. Ethylene, can you tell us what you're working on?
Yes, I'm working on a Nulla switch driver, and I'm doing the SMT rework, which is prior to the verification of the parts, which is prior to the through-hole parts we have to put in the board.
Thank you, Ethylene. After the soldering is completed and the boards pass inspection, they go to test. After they pass tests, they are returned to the through-hole area for staking and government and customer source inspection prior to coating. Coating is performed in this room, which is tightly controlled for temperature and humidity. Cliff, can you tell us about the coating process?
Yes, usually it takes about 5 days to run the boards completely through the conformal coat stage. First, we run the boards over the water wash, and after the water wash, we bring them over and run them through the cleanness tester to make sure the boards are clean of finger salts and contamination and stuff like that. And then we run over to the masking of the boards. And over here is where we do the masking. And Lynn, what are you doing?
I'm masking the board according to print. Wherever you put the masking, the coating won't stick. After completely being masked, it cures for 1 hour and then bakes for 2 hours.
Oh, did I remember to tell you? It's 5 days to conformal coat boards. After they've been in the oven for 2 hours, we bring them over here and we start mixing our conformal coating up according to the EMP. And then after we mix it all up, we pour it into our spray gun where we spray our boards. After our mixture is poured into the spray gun, we spray our boards one coat and then turn it all the way around 180 degrees to get our thickness according to the military specs. After I sprayed the boards to the minimum thickness, I carry them over and put them in the dry box and let them cure for 2 hours. After that, I bring them back, flip them over, and repeat the process. And you spray them 180 degrees and put them back in the dry box where they'll be air cured for minimum of 12 hours. After the air cure, we put them in the oven at 66 degrees C for a minimum of 3 hours. Cured, we bring it over and let Lynn demask it. and she demasks it and does the touch-up for any abnormal coatings before she pull the masking off. And after she does the touch-up, there's a little bit more cure time, and after that it goes straight to QA.
Thank you, Cliff and Lynn. Now we all know why coating takes 5 days. Now let's clear up some confusion about how long coating takes. How long does coating take?
5 days.
5 days.
5 days.
5 days. 5 days.
5 days.
5 days.
5 days.
5 days.
5 days.
5 days.
We hope you have enjoyed this tour of a day in the life of a PC board. Thank you.